Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by Captain John Cordle, U.S. Navy retired, and Chief Warrant Officer Ben Miner, U.S. Navy retired, to discuss the material condition of the fleet through a reflection of their article in the January issue of the U.S. Naval Institute Proceedings entitled Give Navy Crews Painted Ships. John, Ben, thanks for joining me on the podcast. John, indeed, welcome back. Let's introduce ourselves. John, would you introduce yourself to the Talk a Little, Learn a Lot audience?
Sure. I'm a retired Navy captain, Naval Academy graduate, ocean engineer, served on about 7 or 8 ships. I'm a nuke, so pre-com 2 carriers. Served on 3 DDGs, commanded USS Oscar Austin and USS San Jacinto. And in this context, have taken most of my ships in the dry dock or had a major maintenance period. And so that's what, we'll talk about why we wrote the article and stuff like that, but that's my background. Spent about 10 years, 5 years after that, retired in 2013, taught maintenance for the Navy in a group called Maintenance University. So dug into availabilities and work packages, that kind of stuff. Met Ben during that time and learned a lot from him as a port engineer. And then spent the last 5 years as a human systems integration person looking at the people side of things, manning, workload, stuff like that. And I retired in actually last year in May. And gave me more time to write. So here we are.
Well, I enjoy the article, and hopefully you'll give me more fodder for the podcast in the future, and we'll have you on again. So thanks a lot for joining us. Ben, would you introduce yourself, sir?
Sure. Hi. Thanks for having me on. Appreciate that, Steven. So, I came a little bit different route, but enlisted in the Navy in April 2000. Worked my way through various ships as an engineman, and then I actually left active duty about 12 years in. Worked various jobs, field tech, a couple other things, design engineer. Ended up going to Texas A&M Maritime, where I got my bachelor's in marine engineering, my Coast Guard third engineer's license, and a few other things, my FE, a few other collectibles along the way. Went to work. I actually went there specifically to be a port engineer. When I was active duty, I'd met one I thought was just such an amazing job that I oriented my life to kind of go that route. And got picked up for that. So I was a U.S. Navy port engineer for about 7 years on destroyers and cruisers, and I did visiting in foreign ships. That's where I got introduced to different coding styles and different technologies in the foreign fleets. Got my master's in systems engineering from ODU, and I'm finishing up a doctorate in public administration right now. Right now, I'm a type desk, what they call a supervisory program engineer with Military Sea Lift Command. So I have a spectrum across the MSc on that hybrid kind of orientation now as well.
Right on, Ben. Well, welcome. I want to start with a sea story, one that I've talked to John about earlier. Friendly reminder, John and I are both Sandjack sailors. I was on board as a division officer. I was my second Divo tour, and for part of that, I was the first lieutenant. And this is one of these sea stories that I tell people to compare and contrast the U.S. Navy and our approach to preservation compared to other navies. Sandjack was in Naples. Outboard of us was a French frigate. It's raining, and as the first lieutenant, I was out there with my guys, and they were conducting clampdown. This led to a famous quote. One of the sailors looked at me and he said, "You know, sir, only in the United States Navy do we vacuum up water outside while it's raining." And I kind of laughed at that a little bit, but then looked over at this French frigate, and no surprise, they had an awning up, and those guys all like to smoke. There's a lot of smokers, and they're out there, and they're kind of laughing at us as they're seeing us do this, conduct clampdown, getting all the water off the deck. And I noticed two things. One, the French frigate, their deck was cambered, so meaning, higher in the center, slope down, so all the water basically is gently running off of it. And also, all of their overboards are just a little bit over the water line. And, Sanjak, we took a lot of pride in the ship looking good. And one of the things that we would do, because it was a ship that had a lot of overboards that were relatively high, 10, 15 feet off the water line, man, as soon as we came into port, the first two sailors over the side were two of my bosun's mates with a punt and a roll of paint, and we would get in there and immediately start to remove that running rust coming down the side of the ship. And I used to always shake my head and say, why is the ship designed this way? Just nuts. Um, and I know that you gents both have stories similar to that you'll share. The second sea story is I was actually stationed at Naval Station Suda Bay, Crete in December of 2001 when my brother was an exchange officer on the Jacob von Heemskirk, a Dutch frigate. And they were with the Standing NATO Forces Atlantic. And they came into port. I go on board to see him and enjoyed Christmas dinner with the wardroom and everything. And as I'm walking around the ship, I was like, man, this ship is just beautiful. And again, my first lieutenant eyes are still with me, right? And I'm like, holy cow, this is a really beautiful ship. And I said, clearly brand new. And I said, no surprise, you're an exchange officer. They want to put you on one of their newest ships. And he said, nope, not at all. He said, this was commissioned like in the early 80s. I said, you're kidding me. And he recognized and knew what I was talking about immediately. And he said, you know what? He said, I have learned that the crew does very little preservation of their own ship. And he said, when these ships have an availability and they go in the shipyard, they have a shipyard crew comes on board and they, strip, paint, and preserve the entire ship. And they do it with a very high quality paint. And as a result, there's very little preservation that the crew has to do. It wasn't zero, of course. I mean, there were some spots that they would have to address here and there, but he said they put all that work and all that effort when they're in the shipyard so that it's something they don't have to do when they're underway. So when I saw this article and I recognized John's name in Proceedings, I was like, oh my gosh, I have to get these two gentlemen on so that we can talk about this article, this subject. It's something that I know all three of us are passionate about. So let me start by asking you, John, what inspired you to write and give Navy crews painted ship this article and raise this issue?
Hey, thanks, Stephen. And that's how every time we meet, we find something else more common ground. It's kind of funny because I did an exchange tour with the German Navy and had a similar experience with the boot topping overflows. So there's actually two answers to that question. The first was San Jacinto. So I was slated there, Major Command Cruiser, back in 2010, and my wife and I went to lunch before change of command and toured the ship and and I'm excited, man. I got to see, I'm in command of a cruiser. I get back to the car, my wife's in tears. She's literally upset. And I said, "What's the matter, honey?" And she goes, "Did you see that ship? It's a rust bucket." And I'm like, "Well, I mean, I had been on new DDGs, Cole, Artie Burke, Oscar Austin. So this was new to me, and but her perspective was eye opening to me. And it wasn't because they weren't trying, but as you saw, same kind of stories, right? So fast forward, we deploy for 8.5 months. We have a package in to go on the dry dock. And essentially, we get told that, hey, the money to fund the dry dock ate up the money to paint the ship. And so you're not going to get painted while you're in the yards for 12 months, up above the water line, basically. And I fought and I fought. I brought the admiral over and I said, boss, you're going to be chewing out my relief a year from now when the ship comes out looking worse than it does today. And he kind of shook his head and, fast forward, change command. I go off to Surfland, come back. And sure enough, as chief of staff, I'm tasked with chewing out the captain on behalf of my boss for not getting the ship painted. And so that stuck with me. So fast forward 15 years, I'm now a GS at Surfland, and I'm on a ship getting ready for some sleep studies. And the ship had been on Com2X for 6 weeks. Lots of training, radiating, shooting guns, driving around, no time to preserve in the summertime off of Norfolk. And they looked kind of ratty coming back. They have 2 weeks before what they know is an 8-month deployment, right? And the captain's shaking his head. He goes, I'm trying to put people on leave, give people a chance to see their families, but I have to get the ship painted. And the problem is I have to find a barge and a crane and an operator. And there's 9 ships about to deploy. So we're fighting for the same 5 cranes. And so out of 2 weeks, I ended up with 4 days to actually apply paint somewhere. And it wasn't done properly, probably. So we're just going to go on deployment rusty. And it kind of flipped a switch in me. And I said, why is this happening 15 years after I lived with it? Why don't we flip the switch and say, this is not let's not put the burden on the sailors, right? Let's take this on as an enterprise and solve this problem by doing what you just said, right? I mean, the answer is not rocket science. Give the crew painted ships, which was not my title. I have to thank Naval Institute. They came up with that, and but I like it. So sorry, long answer to a short question.
But a good answer. Ben, can you summarize sort of the central thesis of this who haven't necessarily read it?
Yeah, sure. Thanks, Stephen. So I like to think of the article as principally driven towards resource management of sailors' time and resource management. So in the article, there's a good quote in there, a line that I really like. It says, couldn't find a poster that said join the Navy and paint ships. So I mean, that's what it is, right? So we spend a significant amount of time training our sailors. You could think of sonar technicians, enginemen, I guess we're kind of winding down those. So machinist mates, take your pick, right? OSs, even the bosun mates, kind of train them up. And then we, put a needle gun in their hand and kind of push them to preserve, right? And then anyone who's been afloat on these ships can tell you that there's another line that goes around once for rust, twice for dust. So we don't have a lot of time, right? Again, you're very resource constrained, both time and actual physical resources. And so you do what you can, right? You paint over that area that maybe you should have taken down to bare metal, and you move on. But then, as I think John had a good story, I think it was about having his sailors spend 2 days painting a small area, 3x3 area, only for it to rust over again, 2 weeks later or a week later or something. I mean, that happens a lot. So I think we just kind of have to think differently on how we leverage shore resources and the capabilities and what we want to empower our sailors to do. And that's really what the article's about is, you have, again, finite number of sailors and definitely a set of skills on board. And how do you want to leverage those? Do we want to spend that time, week over week over week preserving areas, or do you want them to do their job, maintain equipment, and track, what we need them to track? I think also I'd say that this meets the CNO's efforts to build up the industrial base. So if you've read his the Sea Power that he put out, he talks a lot about that, and I'd argue that's what exactly this does, and that's what the article is based on.
John, what specific design features in the current U.S. Navy ships contribute most to the corrosion issues and why?
Hey, great question. I'd just like to add that the in the story that Ben just told about that 3 foot by 3 foot, that was me. I actually was bored on deployment. I tried to do that preservation with supervision from my bosun's mate, and after I think
Is that
22 man hours, failed
is that why
miserably.
is that why it came
Uh,
up?
yeah, everybody was
I mean,
taking pictures of the captain trying to needle gun and paint. I did a crappy job, but yeah. So I mean, there's a long list here, right? And none of this is intentional, and I don't mean to disparage the shipbuilder, but I think it goes back to your point with the, what's the end in mind, right? And can we design corrosion resistance into the ship? So bridge windows, is one area. Part of it is the design. Part of it is the accessibility, right? The anchor windlass, some of the machinery that is exposed to the weather and yet is adjacent to areas where you just can't get in there to deck drains. Can you not weld them in place but have them screw in or have a print them with some non-ferrous material? Fasteners up topside. You know, we paid, I don't know how much, Ben. You could probably find a number, $10,000 to replace a sound-powered phone jack on the bridge. When if we had replaced the cover with an AM printed plastic cover, we probably would have saved it from the corrosion. So they're all over the ship, and those are just a few. The overboard discharges we talked about are a huge one, and but getting at the design features from a holistic corrosion standpoint, I think has to be part of the solution.
Ben, what do you think about how much of this corrosion and maintenance comes from the design versus the maintenance practices?
Yeah, I appreciate that. I think those are one and the same, so they kind of relate to each other. When you choose a design structure, so right now, actually, I'm part of getting ships out of new construction through to delivery and into the field, and out to sea. And I think when you choose a design structure system, principally we look at functionality. And as the ships get older, we start to shoehorn these alterations in, and you look for, location and functionality and operations over the preservation and maintenance. And there's lots and lots of examples of that. I'd say, um, for instance, RAST is a good one. So I used to be a RAST tech way back in the day. So recoveries, assist, secure, and traverse. That's the system for helo recoveries. And on those spaces, you have to put them aft. You have to put them below the flight deck. They're pretty, strategically located, principally so you can actually run them over the deck too, and for the cabling. But that's functionality. That's a design choice that we've made. But I would argue you can't go in the RAST room while it's running. And when you're underway, like John talked about, when you're doing operations, that means there is no preservation. There's nothing happening back there. And oil spills on deck. It gets under the non-skid. It gets under the paint. The cables, as the spools are moving, sometimes that causes some friction and heat back there, and that starts to take up paint. And so as John talked about, you need at least 2 days to get back there to do any sort of preservation. And I'd like to see a flight capable ship that can give you 2 full days where you can actually do that properly. And so there you are, 3, 4, 6 months later, where that coating has come up because it was improperly applied the first time. Because we couldn't also get back there to do some of the work with that design choice that we made. I know, I would say, I've talked to NAVSEA engineers before. I know that maintenance practices are they try to tie them into the design choices, but principally that's the front runner. That's what we make. I'd also just add one thing in there, as the article suggests. We do talk about alternate coatings, and I think we get into that a little bit later. But polysiloxane has really come out as a great choice for maintaining a solid coating in the areas that we're talking about here. Also high solids, and this is where we talk about thinking differently about where we apply paint and what we're looking to do. So traditionally, let's say again, just not to pick on the destroyers, but I will, back aft by the paint locker and stuff, it's all non-skid back there. And anyone knows you spill paint on that and you start to, it gets so worn up. And then you also have the repair locker back there. I mean, it just gets tore up so fast. I know as a port engineer, I kind of made the call, and I might dime myself out, but I'm no longer a Navy port engineer, so I can do that. That I switched to high solids. And so high solids on the deck, even though it's much more complicated to put, if you do it right, it lasts just forever. I mean, it's made for high traffic. It's made for exactly what I'm talking about. And so I think that's part of it. Is in operations, we also have to kind of iterate and look back at what those design choices were and how we can kind of better those for the maintenance practices that we're looking to improve. Thanks.
John, to what extent do the design features hinder crew efficiency and operational readiness?
I'm going to answer with a sea story. So I found out long after I had left command of Oscar Austin that apparently I had thrown my shoes at an in-service inspector while I was in command. The story goes a little bit differently. The RAS track that Ben was talking about, we had been on like day 4 of in-serve, and they had done all the inspections. I thought we were wrapping up, and the flight deck guy came to me and said, we're going to have your crew take up the plates on the RAST. Well, if you've seen that, there's about 2 times 60 feet of 3-foot steel plates bolted down to get underneath to get inside that track, which is inaccessible underway. And he wanted them taken apart by the next morning for inspection. It's August. I had my I was up on the deck, and I sort of lost my mind. Right, I decided to control myself. I would walk back to the aft flight deck and or to the stern. In the process, my left shoe came untied, and in frustration, I kicked my left foot, and my left shoe went flying into the water. I looked down at my feet and said, well, what good is one shoe? So I took off my right shoe and tossed it about as far as I could off the stern, and stormed into my stateroom to just fume. And we ended up taking everything up, and we cleaned it, and it was fine. Well, the next day when I got to work, my boots were outside my stateroom door, just caked in salt. But the bosun mate said, I wanted to save them for you. So they put a boat in and went and retrieved my boots. But that turned into, I was an SNA lunch about 2 years later, and some JO was talking about, yeah, are you the guy that threw his shoes at the in-serve inspector? And I'm like, no, that's not what happened. But it relates to your question of how does it impact readiness, right? That's just time spent. We should be worried about shooting down drones and force protection and training, not pulling chunks of rust off of the bridge windows or things like that. So I'm an HSI, human factors engineer. It's all about how much time do I have in the day. But I'm also part of HSI, which people don't realize is back to our old podcast, the maintenance design. You don't design stuff just to operate. You design it, and there are rules on how heavy can it be, how accessible must it be, and we routinely waive those rules to build ships. And so we need to go back to some extent, just doing what we're supposed to, you know.
Ben, what materials or coatings have proven most effective in mitigating corrosion in naval environments?
Yeah, thanks. I'd also want to comment. I was an in-serv inspector, but I was not the in-serv inspector that John threw his shoes at. So that's just to get that out there. Yeah. So I'm not sure it'd be so much as the coating type. We talk about specific materials or coatings. I think it's more about the right coating type for its applications. There's obviously no one for all. I think one of the comments in our article, that feedback was about changing out the materials topside and why we use mild steel topside for things like gauge panels, fasteners, things like that, and how they're easily corrodable. And I think all that's right. But I'll give you another example. Is that in reach rods through tanks, sometimes we use a high quality stainless steel. So if you use, for instance, if there's a reach rod that has knuckles that pass through a ballast tank, you would say, let's use stainless steel, which makes sense, right? You don't want to have corrosion. But if you use a 400 series, a 400 grade steel, like a what 416 I think it is, or 410, but those actually are that would be the wrong material. So even though it seems like a high quality stainless that you put in there, those are actually highly corrodable and susceptible to failure in when exposed to seawater. So it's really about the right material and the right coatings for their application. The other one, I'll just add a couple more really quick, is in new construction, like John talked about on the plating, we put a barrier coat called mill scale on the plating when it gets purchased. Then the plates actually get usually held outside. They allow them to surface rust because what happens is you take the plate and you run it through an abrader, and the steel abrader takes up the mill scale, and then, of course, you blast it and everything else, and you put it into its place through tack welding, etc. But the abrader dulls, right? And you can actually just like a needle gun or a deck crawler, you can actually embed the mill scale into the paint, which it would look like you have a good profile. It looks like you can apply the paint properly, but it turns out the paint actually just it comes right off, right? So it's the preparation is just absolutely critical, and then knowing what to put on that and how to prepare and take up that plating would be more important than the actual type of primer or paint they had put on. I would add a few just things that I've seen the Navy kind of take up recently I thought were really good. So I'd be remiss not to mention those. As the Navy started adopting a model MSC has been using for quite a while, which is hiring a paint representative, SME, on site to ensure proper paint application. But that's only during depot periods. So, right. So we actually do that for the contractor. We bring an SME on and we make sure that we're getting the product that we wanted to. And there's some nuances to that. So any Marmic or RMC project manager or shipbuilding specialist out there can comment on how we still have some distance to go on that one. But it does work. But we don't do it for ships in operation, right? So we have CCAT, we have a few other guys we provide out there, but we do it for a contractor. And we don't do it for ourselves. So I think that's a missed opportunity. And then I would say also that Naval Surface Warfare Command and Naval Research Laboratory, I've worked with them for some time in identifying alternative materials for the fleet. And one might think, listening to this, you say, well, what about manpower, getting out there, identifying the right material and stuff? Look, the fleet gives feedback, right? As John talked about, you don't need to do much more than walk down the pier and you can identify a few candidates just on your own. It's not too difficult. RMCs are helping on that end. I would probably comment it's a little slower than we'd like, but but shifting to composites for eyebrows, the deck drains, hull drains, strengthened polymer gauges, the exterior applications, again, shifting over to the proper stainless would really just save absolutely in costly repairs. A quick another example of I talked about the gauge board. So when you attach a gauge board to the bulkhead, wind into those it's fasteners, it's connection points. Those develop holes around them all the time. I mean, that's crevice corrosion. So you develop strain and crevice corrosion around that. And now you're replacing steel instead of just a gauge board or a fastener. So thanks.
John, how do steel fasteners and drainage routes contribute to rust formation, and what alternatives should be considered?
Yeah, I think, Ben hit on a bunch of these, but I think, there's a long list. I have a great brief from NAVC on composite materials. And I think the paradigm shift, if you will, and the editors of Proceedings took the word paradigm out of the article, and they probably rightly so because it sounds so esoteric. But the paradigm shift is right now, if you identify a problem, you document it with a 2 kilo, you get it screened, it gets put into a work package, and that individual problem will get addressed. Maybe it's paid for. What we're advocating for is a complete revamp of the program. So when a ship goes into the yards, you take off all of those scuppers and you replace them all with the non-corrosive ones. You remove all the deck trains. Now, when I say remove, you're talking about cutting metal. You're talking about surface preparation, which is very important. So you don't just have a TAD force who happens to be coming to work that day. You have trained operators with supervision doing it. The ready service lockers up topside, the sun shields, if you remember those things, you probably mess with those. You try to needle gun them and they bend, or you poke a hole in it. It's impossible to get them off because the bolts are rusted from that crevice corrosion. Let's just go in and swap all those suckers out, right? Plus, let's not make them out of metal, right? They're supposed to keep the things cool. The list could go on. I don't know how you would get at it, but bridge windows. One of my friends talked about literally reaching his hand outside and pulling off a half-inch, three-quarter-inch chunk of the bridge window that had corroded and just layers of stuff. There has to be a better design for that, right? It's got to be blast, shock tested. It's got to be CBR compliant, whatever. But there has to be a better way. So just rerouting the water so it doesn't flow topside. When I showed up on San Jack, I brought a leaf blower in for clamp down for the quarterdeck. So they just they put on goggles and blew the water over the side. That was a little more efficient. Of course, if it's you while it's raining, it doesn't help. But this is not rocket science. But as Mark Latner wrote an article and spoke at ASNE about this, and he had a great quote. Says, "We know exactly what we have to do. We've just chosen not to do it." And so we're advocating is the SecNav talked about going to a wartime footing, right? And SecDef or SecWar spoke to the shipbuilders, I guess, and said they need to step it up. Well, my message back to them is let's step it up ourselves. And like Ben said, let's take these things that we know work, let's pay for them, and let's get them down to the ships as if we were at war. And because we might be, you know. I know I diverted from the question, but sorry.
Oh, it's all good. It's a discussion. Ben, can you discuss the trade-offs between corrosion-resistant materials and other shipbuilding priorities?
Yeah, I think you keep that one short. That's a rabbit hole for sure. I think we do incline experiments. We do a lot of checks on the ships to make sure that we're kind of keeping within the weight distribution, and certainly cost and availability are well, you would think they're a factor. Sometimes they're a factor, sometimes they're not. I would actually argue functionality and operations tend to often take precedence over the availability. Um, in my undergraduate, I was pretty fascinated with material science. That was actually the route I was thinking about going originally. It's something I really studied professionally, and I still read about it. I really like it. But in material science, you get so caught up in what the composition of material things are. But I know, having been an operator and been on the ship myself, I often think, everything is a trade-off, everything. And I think if you're going to really succeed with maintaining the cost and longevity of materials, you have to have somebody who's capable of marrying that theory and the practical. And I actually, what I would say, I worked with NAVSEA for quite some time and building up their AM catalog, and that's something where the feedback from the fleet was absolutely crucial. So I did it through reservists. So I was, like I said, I was active about 12 years, and I was reserves about 13. And with the reserve, I would put sailors on orders, send them out to the fleet, and just talk to the sailors on the deck and collect feedback. So as you mentioned, first lieutenants, the ops. I mean, these guys, XOs, they have feedback. They see it. It's not like they don't see it. It's just that they're limited in the resource capability to do anything about it. So we would empower the reservists to collect the feedback, put that back to NAVC, and then work on identifying corrosion resistant materials or alternatives to help buy down those problems. One last thing, with the cost, so the cost and weight availability. John talks a lot about, and he's got some other articles about additive manufacturing, and alternative printing, things like that. Uh, that to me is, I mean, that's what exactly that is. So if you could empower the fleet with being able to print their own materials, I mean, you really, it's significant, right? The paint on a ship has a significant weight, right? So we should factor that in, consider that. If you could buy that down, that's huge, right? It's
That's a great
absolutely
point.
huge.
That's
Yeah.
a great point.
So that's what I got. Hopefully I answered all that. Okay. It's, again, I really think that one question could really be that could be a whole show.
And maybe we'll do a part 2 at some point. I don't know. John, how does corrosion affect everyday life and the workload for the ship's crews at sea?
Yeah, great question. You're hitting on my human factors background there, right? So
Indeed.
there's a calculation for the workload, and almost everything is underestimated, I think, but certainly painting. I remember when I was teaching at Maintenance University, one of my students said, my BMC told me just put in a 2 kilo, into the CSFP every day, 8 hours of work for painting and corrosion control to beef up manning. It doesn't really work that way, but that was the thought process. But you know, I pull out the cruise book from San Jacinto, and the cruise before mine was in my stateroom. There were 36 bosun mates. When I deployed, I had 18. I just did a ship investigation for something else, um, but part of it was look at manning. And on aircraft carrier, I think the bosun mates were manned at 60%. And so, an alternative article title was, who's left to paint. And so you can give the ships all these great tools, but if there's nobody there to use them, that's part of the problem. So the workload, we underestimated already. We've added now, an hour per day for physical training, right? Another unresourced requirement. That's, could translate into either less painting or less sleep, right? Well, there's only two options really, because you have to do that now. As Ben talked about, it's all a trade-off, but and it's not just the bosun mates, right? I mean, most ships are this way. A department owns a section topside, whether it has anything to do with that department or not. So I could be a fire controlman, just finished 9 months of Aegis school. Welcome aboard. Here's a needle gun. You own the forward spy array, right? Et cetera, et cetera. So it really adds up. I don't think we capture it well. And I don't think we capture the risk and the cost of underfunding it and undermanning it well in terms of human capital, even something like retention, recruitment. And I think my favorite line in the article was you never see a recruiting poster, join the Navy, paint ships, right? That's not what these folks join the Navy to do, right? And so let's have somebody else do it. And back to Ben's point, let's have someone who actually knows what they're doing come and do it. But yeah, that's there's a mathematical answer to this question, but you kind of get the drift.
Ben, what maintenance tasks take up the most crew time related to preserving the hull coatings?
So I I would say it's preparation, 100% proper preparation. So you could, in a layman's sense, so the once for rust, twice for dust, I could just get a bucket of paint from the paint locker and, roll it on over everything on deck, right? But as you know, that's going to come up almost right away. So it does no good. But you're talking, let's take like a four square foot area, semi-corroded, maybe I don't know, like if you use the S&P conditions, you probably like an S5 or S6 or something. So kind of like corrosion over it. But you're talking, again, 4 square foot, probably an hour, 2 hours for paint, scraping, sanding, right? You got to sand it down. You're gonna have to feather it in. You have to tape off the area, clean it. Then you have to degrease it. That's another hour or so. Um, then if you're lucky, if you're able to get in the paint locker when it's open and you had your prime coat on deck, good on you. But that's another hour, 2 hours. And typically we use an A and B primer. So then you have to also use that's 2 coatings, right? Either mix them or you're gonna have to wait some period and put maybe 2 coats on there to do it right. Then you let it sit, right? That's a curing time. Assuming you've done that correctly, then you have to put a top coat and sealer, and that's going to be another, hour, 2 hours. There's an 8 hour day, right? So you've eaten up an 8 hour day. And if I was short, anyone who's had to manage a division knows you on paper you get 10 sailors, 15 sailors, but that's not the reality. You don't really have that number of sailors. So I've taken one of my sailors out from work for 1 to 3 days for a 4 square foot area. And that, we didn't even talk about like, top maybe top side under one of the T beams, right? So we're trying to get in one of the channels or one of the more difficult areas, cableways. So we didn't really talk about that, but cableways often are preventative of being able to get in the overhead. But that's where the corrosion happens. You're having those areas where you build up condensation, it's raining down the space, hatch channels, things like that are difficult to get to. And like John talked about, if you may be unfortunate to a degree where it's up at the O5 or radar levels where you can't even get up there. So you may have a day to be able to preserve. So you need to go at it fast. And that preparation is just absolutely critical. So that really, really takes up a lot of time. I have worked with CCAT quite a few times, and I know they put a significant emphasis on preparation and training the sailors to do just that. So I think that's probably where most of the time happens. Gets eaten up anyway.
John, are there examples of ships or classes of ship that have design features in them that minimize these rust issues?
Uh, sure. We've already talked about a few of them. Just to pile on to Ben's answer about the paint piece, one thing that Mark Latler talked about is, and I've seen these come out, they're like a paint mixing kit, right? So instead of going to get a coffee can and 2 5-gallon buckets and dipping it in and mixing it, you get basically kind of like the old epoxy things where you squirt one, squirt the other, mix it together. Um, but those things hold like, I don't know, maybe a quart or half a gallon of paint. Talking to one of the COs, they're awesome, but I would need like 1,000 of them, and then they have cleaning kits to clean off the rust, like you talked about. For this Polyflex Flat paint is actually a anti-graffiti paint. That's where it came from. And there's kits to clean that stuff off, but you go through them so rapidly, and so there's solutions out there, but do they match the real requirements on the deck plate, right? As far as the one mention I'll make out of my old boss, Admiral Thomas used to come back with his head shaking. LPD-17 class had these large areas because of radar cross section that had funny angles and stuff like that, and they had this whole area that was all encompassed by steel plate, like a big pyramid type of thing, and at the bottom of it was a small drainage hole. Um, and uh, and then basically what would happen would be the inside of that space would corrode, and then all the rust would come out. That one little 1 inch hole, and the entire deck for 40 feet, 10 feet wide was rust covered, and you could do nothing about it, right? And so something as simple as that became a huge headache. And but you'd have to go back to the ship design to really change it. DDG uptakes are another example. Intakes and uptakes, incredibly difficult to access, to assess. They even have started doing drones. They put them in there, and the drone flies up and photographs. But that's not an easy task, right? That takes some skill. So, yeah, those are just two examples where design features really, really bite you. Retracting things like retracting bits and ballers that you put a cover on the flight deck and then you drop it down with a gear, and it sits in a hole. It fills with water. Those types of things just come back to bite you.
I want to take a pause for a minute and mention that ASNE has an event that's going to focus on preservation called Mega Rust. Mega Rust is scheduled for June 2 to 4, 2026 at the Marriott Mission Valley in San Diego, California. It's conducted annually to provide a consolidated focus on Navy corrosion issues. Corrosion, as we've been discussing, is a major factor in the readiness and total ownership of naval systems, and the conference is intended to provide updated information on programs, policies, standard, and fleet experience related to corrosion and to promote discussion and sharing of information on technologies and strategies for controlling corrosion. It provides a impartial forum for dialogue between government and commercial organizations and providers of coatings, corrosion control products, processes, technologies, and solutions. Participants will include representatives from the military, industry, and government organizations involved with research and development, design, engineering, construction, maintenance, modernization, and operation of naval systems that are potentially affected by corrosion. The conference is going to cover all segments of the naval services, including sea, air, Marine Corps vehicles, and facilities. Any and all information that the Talk a Little, Learn a Lot audience might want to have on MegaRust is on the ASNE's website. It's www.navalengineers.org/symposia/MegaRust 2026, and I will put a link in the show notes. Ben, what are the broader operational impacts of corrosion-related maintenance on fleet readiness?
Yeah, so as a port engineer, I think I really saw that a lot, especially working with the ops changs, COs, XOs, and any port engineer will tell you out there the growth in steel replacement can really drive your maintenance period. And that can be as simple as like piping, for instance. So pipe degradation falls into a similar thing, similar realm when we're talking about corrosion and preservation. So I'll give you a couple examples and kind of go through those a little bit, but intakes on a DDG, for instance, require significant containment in stainless steel welding. So if you go through the clean sides, you have to take down perforated stainless sheets. That's a different type of welding. That type of containment itself can eat up a lot of time. And you know, how do you get in there, right? So I mean, it's very difficult, and you don't really know that until you start to take down sheeting or do some really up close inspections. Same for the blow-in doors, right? The blow-in doors, when you have gas turbines, are another really difficult item to get take a look around the channels and get in there, particularly when you're underway, which is really where you see the lion's share majority of that degradation happen. On a cruiser, for instance, so anyone who's been on a cruiser knows he has a bimetallic strip. So you could have a part where you're doing steel welding and almost go immediately into aluminum welding. And that itself takes a certain set of skills, right? We train people specifically for that. The list goes on. You can go on, again, a whole show about something like that with specific design characteristics and how those drive the availabilities. But I think while the impacts on maintenance repair are pretty clear, and you could probably find those pretty quickly through research into what we call RCCs, so requests for contract changes that happen during availabilities. And we have significant research and literature on case studies. I think the real issue that I would see often, especially talk with the operational guys, is the non-dollar figures. So, you know, corroded combing around a hatch, I mentioned that before, is an internal space degradation. And what happens is then you have the inability to prevent cross compartment and smoke contamination, right? So if you had a fire, that's going to go through those nooks, and if you've ever been in a fire underway, it's absolutely terrifying, right? And having that smoke cross contaminate is terrible because it sends false signals for where the fire's at, and it could harm people. Same for cross flooding. We put a ton of effort into cross flooding ducts and designing ships to support you know, compartmentalization. Even more so since the El Faro incident. American Bureau of Shipping's put a lot of effort into mitigating cross flooding, putting boundaries in place. But you know, the minute you lose preservation in space, you develop holes, that's all gone, right? Then now you have real problems with that. Another part I'd just point out too, and I used to talk to sailors about this, was just how it affects them in morale. You know, you think about these sailors, they live on the ship, right? You live on there for a significant portion of your life. My first ship, I was on there for 5 years. And I saw the rust, right? Often I would have to sleep next to the rust. And it sucks, right? It's not great. It causes stress, anxiety, and you just don't like it. Nobody wants to live in a messy house like that. Another one was cracked decks and PRC. PRC, unfortunately, when you drop things on it, if it incurs a lot of stress, it can crack, it can break if it's not applied properly, and that's what I was talking about. Shifting to something like a high solids is pretty helpful. But the main thing is the broader operational impacts. If I'm not ready, and I don't complete my maintenance availability on time, somebody has to pick up that slack, right? Somebody else is going to go underway and have to take that up. And I think I would argue probably there's no CO out there who wants to have that happen to them, but some of us have had to surge deploy, and that also takes a toll. So I think there's a couple different aspects and dimensions to that question where you see that on the fleet readiness.
John, do rust and paint degradation have measurable impact on sensor performance or on stealth characteristics on board ships?
No, great question, especially as we talk about kind of the wartime impact of this. I think, certainly any specific answer would be classified probably, but, two things I can talk to is one, the designer ships we talked about with the LPD-17, there's an impact there because that's a stealth design that causes a corrosion problem. The other thing that came to mind was the cruisers are covered with this sort of spongy, reflective radar absorbing material. I forget what it's called. That stuff is glued on with like some crazy epoxy mixture stuff. So you almost never, there's like the PMS to replace small areas of it. Every time we took that stuff off, behind it
I
was
think it's
horrible, right?
PCMS, right? The passive
PCMS, right?
countermeasure
Thanks.
Yep.
Every time we took that stuff off, it was a pain to preserve and then to reapply properly. So you degrade it by trying to fix it, right? The other thing is if you paint over it, because it might start to look nasty, it looks better, but now it doesn't work like it's supposed to because the actual surface of the material is what makes it, work. So those are two pieces I could think of, and then certainly degradation of a radar foundation could cause it to be off kilter and be out of spec. Weapons performance, VLS hatches, so there are, and maybe that's a talking point that needs to have a little more visibility is the direct tie between corrosion and and wartime operational performance. That's a great point. The windows I talked about, the angle of the windows is important, and the rust up there, if it changes the profile of the ship, could cause a radar return change. I guess those are some things I could think of.
Ben, can you speak to how maintenance burdens interact with the deployment tempo and readiness cycles?
Yeah. So I mentioned before, I'm not sure if either of you, I'm sure John has for 100%, I'm sure, been surges deployed. So that kind of that no notice, come back from deployment. I know the last ship I was on for active duty, we had deployment, came back. I was in for about 3 months and I got hit with another deployment, went right back out for another year. So my first 2 years of marriage, very difficult, I would tell you. Didn't see much of the wife, and probably you guys have been there too. And it's hard, it's very tough. But I think more than that, the OFRP, the Optimized Fleet Readiness Plan, doesn't stop, right? It runs its gamut. So the Navy runs a optimized fleet readiness plan. It has a sequence of events. It kind of leads to a deployment phase, goes through its various phases, but that's all predicated on each ship being able to complete their events on time and support each other. And as we talked about in here, that doesn't always happen. As you incur growth, you incur new work. I pull a blow-in door and find a corroded coaming. That avail window is gone, right? You may have 3 to 6 months, but now I have to replace channels and I have to do alignment. You have to do the light pass checks, all sorts of stuff. And that sounds fairly easy, but sailors have been killed doing things like that, right? You have to be very careful when you do event work like that. So it's not uncommon to incur a chain of events that blows your pop. If the ship was slated for operations in the Vale, someone's gonna have to take up that slack. I know I was in Japan as a repair officer for a while, and we would do SIAs, the ship intermediate availabilities, to kind of mitigate that. MSC does something similar. They take an annual, the SIA is what we say, ship intermediate avail, but in MSC we call them ROHs and MTAs. It's just regular overhauls and midterm availabilities. But for the combatants, you may be talking a 3 to 5 year cycle on major availabilities, right? CNO availabilities. And if you find it as a port engineer, the maintenance team, you may not have the option to defer it. In fact, you probably don't want to defer, right? No CO out there wants to have holes in their stacks or look like that. So you do the work, but unfortunately, that eats the time, and that ends up translating into deployment tempo and readiness cycles for others.
John, I'm interested. Could automation or AI assisted surface monitoring reduce the crew burden for corrosion detection and painting?
That's a great question, and the audience missed it, but I volunteered to take it despite having no knowledge of AI. Um, I probably avoided knowledge of AI until I realized that you really can't. But as I think about it, I had a couple of ideas that Ben may also think of more. But we have data, right? I mean, every insert goes onto a ship and collects an entire database of corrosion. Mark Latmer talked about going on and giving the ships a corrosion number, a corrosion ranking. Um, and AI could speed that up dramatically, right? AI could tell you, okay, I have 100 DDG, I have 70 DDGs. Let's go back and look at all that data in the RCCs and the what corrosion. Where are the areas that have had the most dollars spent, time spent fixing corrosion? Let's prioritize those and let's get at that. Let's move that to the left, right? So AI could do a lot, I think, in just the consuming of data that's now done by people with pencils, right? And point us in the right direction. SurfMap, the surface Mega Rust, I'm sure there's a company at Megarust who's probably building an AI function for that. The other thing I was thinking, you talk about surface monitoring. I have to think there are ways that you could build in, for the PCMS, I know there was a way they could sort of look through it and figure out what the surface looks like behind it with some pretty good fidelity. And so perhaps if there were some sort of built-in monitoring system. I don't know what that would look like, but they could feed that data back. Maybe it could measure, I don't know, the electronic resistance across a certain piece of metal and tell you when it was corroded to a point where it needed replacement. So I think there's opportunities there. Some of those would have to be designed in from the get-go, and some of those could be sort of added on later. But I definitely think that, and all that adds up to less crew burden, right? Because somebody else is doing the analysis and somebody else is just targeting us in the most effective use of our time.
Ben, are there emerging coatings, material science advances, or surface treatments that could revolutionize how naval ships are protected against corrosion?
Yeah, thanks. So yes, absolutely. This is, to get at those though, I just kind of go back to something I said before, which is feedback from the fleet. In a brief to the Armed Service Committee, Ron O'Rourke, he works for Congressional Research Services, did a brief on the state of U.S. shipping. If no one's read it, I'd highly recommend it. And he talks about that feedback and the iteration necessary to kind of get our shipbuilding state, within the United States back up to where it really needs to be on that wartime footing that John had mentioned. So this is part of that, I think, which is identifying what emerging coatings and material sciences and treatments, et cetera, that we really need. I'd add a few that we don't, often when we think about this, and particularly for material scientists out there, we think about like what's the next greatest thing, right? What's the next greatest steel that we're going to create, right? But really, it doesn't have to be so high tech. I give some credit to Naval Surface Warfare Command again. Nomex, if anyone's familiar with Nomex tiles, that's a real problem. So in combat spaces or the some more sensitive spaces, we put these Nomex tiles down. They require special handling. They chip all the time. If you don't put the fasteners in correctly, you can damage them and you have to replace the tile. They are a pain in the butt. And often they get uneven, right, when they get warped or liquids on them, unfortunately. NSWC created aluminum and wood paneling. They're really, really easy designs. They're very low cost and they work exactly the same, same acoustics, etc. So we saved, I worked with them to put them on the ship I was port engineer of at the time. We saved thousands in costs and hours in special handling and forming. Those typically go to a depot, a depot maintenance availability, where the contractor has to set up a special workstation to handle them. Makes no sense, right? So we can kind of go low tech and still get around some of the problems that we're seeing. I'd also kind of make a foot stomp on additive manufacturing. So I'm a huge fan of additive manufacturing. I think the Navy really, really needs to put significant effort into this. And principally, in fact, there's an AM partner I work with. And we talk about stick welding. So stick welding was discovered as a suitable method of construction and repair in the late 1800s. It's about 1890-ish, 1894. The U.S. Navy didn't adopt it till World War II, right? We knew about it, but we continued riveting, right? So those exist now. I mean, those technologies are here. In the modern era, I'd say, again, really big fan of AM. Composites are huge. And then being able to kind of look low tech and how we can kind of get that organizational capability back to the ship, I think is really, really where we really need to put that focus. And that's, again, that goes back to the article, right? Being able to leverage shore side to give the organizational capability back to the ship. So thanks.
I'd like to close out by asking both of you gentlemen the same question. I will start with John. So, looking forward, what is your biggest recommendation to naval engineers and leaders to improve ship longevity and reduce the crew maintenance burden, obviously, around this whole issue of ship preservation?
Hey, great question. You're gonna hate me for this, but I'm gonna take a dime back for one thing on the coatings and advances. So in 2010, they brought aboard an experimental dry ice machine aboard Sanjak. Um, and this thing shot out little crystals of dry ice that acted like sand and took off. You could dial it in to remove, flash rust, surface rust, or paint. And this thing would take 5 layers of paint off in a heartbeat. I don't know where it all went, but it all vaporized, right? They wanted to do 10 square feet. They did it. It was a night and day difference. And so I talked them into keeping the machine on board for the weekend, and we did the whole flight deck, and it really made a huge difference. Um, there's a laser paint removal process that I'm not that familiar with, but let's get those things out to the ships, right? I was talking to a lot of commanding officers commented on this article, and one of them said these are great, but they're not making it to the waterfront, right? And so as Ben talked about, something as simple as a paint float, which I didn't even I had to think about a little bit, but if I'm a Norfolk ship, I have a paint barge that I have to tugboat over. It has to be moved with a tug. It's very, very cumbersome. It can poke holes in the ship, and has. I have to have a crane on top of that with a crane operator, and I have to arrange all that myself, right? So I was thinking, hey, just make that a package that we can bring over to the ship as part of the part of. Well, I talked to a ship out of San Diego, and they said we don't do that. We have paint floats that you can pull right up against the ship. It's 3 stories of scaffolding on a floating thing, and you can control it all within the ship's control, right? But they don't have those in Norfolk. I found out Mayport has 2 cranes for 20 ships, right? The math doesn't work, right? So sometimes it's not a high tech solution. It's, hey, let's listen to the waterfront operators and solve those problems so that they can move ahead, right? Um, the type commander goes down to the ships every day and takes photographs. They call it the good, bad, and the ugly report. And they blast out a PowerPoint with photographs and name names and call people out. They don't even, they used to give a grace period before deployment. Now I heard that's gone away. So you welcome home, your ship looks like crap. Um, now go see your family, right? I mean, I was on San Jacinto. Bosa mate came into the XO's cabin while I was there. It was day 31 of their post deployment leave period, and Bosa mate's in tears because the captain had gotten a blast. So they gave him a grace period of 30 days, but they expected the ship to be fully painted after that 30 days when you're actually supposed to be pinning people on leave. And the boatswain was in tears, and he says, Captain, I would have canceled my leave and stayed here if I knew you were going to get a face shot, because of your rusty ship. And so, my response would be, hey, how about instead of sending people down with cameras, send people down with paintbrushes, boss. Um, but so I think back to your question, if I had a recommendation, it would be, hey, get down to the waterfront and listen to the folks. And I think people are doing that, but I think we need to do more of that. And then the paradigm shift is incentivized on the design side. Let's really make corrosion resistance and corrosion control a fundamental requirement in the design of our next frigate, right, or the battleship, right? Um, and so that's thing one. Thing two is let's mobilize the new SEMA capability that CNO talks about, and instead of making it a pull system for these new technologies, make it a push system. The ship goes in a CMAV, we're going to replace 30 overboard discharges, right? The next time we're going to do 30 more. By the time you deploy, we've got them all, and you don't have running rust, right? Let's replace all those RSL lockers. Let's flood the ship with those paint, mixer kits, and those graffiti removal kits. And let's put a truck on the pier that's got that stuff, right? Let's bring the CCAT team down. Let's focus on those pre-deployment periods when we can put those resources where it counts, so that the ship deploys for 9 months. I have a picture of a ship, new non-skid before deployment, and then rusted out. And it's not the non-skid that's rusting; it's the anchor windlass that's rusting and flowing this, river of rust down the ship. If we'd have fixed that one little area before deployment, we wouldn't have that problem. So those are my two. If we could change the way we're doing things, put that burden on AFC and the maintenance community, to design better ships from a corrosion standpoint, and to really attack with a wartime footing, right? And as SecNav said, with what did he call it? Radical transparency. And those are hard discussions to have, because a lot of folks, often come back, well, we're doing that stuff. Okay, great. Let's do a heck of a lot more of it, and let's do it now, because we might be at war in a year. So those are my thoughts. Oh, one more. There's 20,000 gaps at sea, according to another recent article. It's going to take 3 years to close. And so we don't have time to let that problem solve itself. And oh, by the way, it's not gonna. It's another podcast, but we don't have that kind of time, right? And so let's act like it.
Yeah, indeed. And how about you, Ben? What's your biggest recommendation?
Well, my first one would be to take myself off mute before talking. That'd be the so I kind of, I think it runs parallel to what John was talking about. So mine is always schedule time for maintenance, or the maintenance will schedule it for you. So any sailor out there has had to operate on a ship that did delayed or deferred maintenance periods knows you can do it for only so long, and eventually the ship's going to reach a point where you have to pull in, and at that point it's significant. Now you're talking emergent funds and offsetting shipyard availabilities, where the shipyards themselves have to prepare and set up themselves to take ships, and then you basically truncate or lay waste to their scheduling, and that comes at a cost, both human capital and material and dollars. I think it's interesting we get caught up in the ensuring the operation ship that we forget the time to do things right, and that's really what the core of all this is about: is doing it right and buying the time back. So even though it seems like an upfront cost, we talked about one of the biggest draws of preservation or maintenance is preparation, is doing it right up front. And even though that seems like a lot of time, having to do it twice is more time, right? So that's what I'd say. The other one, the one part of your question I have issue with is that I'm not sure that we should reduce the maintenance burden. So I'd say we just need to kind of redirect it. So if you trust your folks to do maintenance or repairs, you have to give them time to be able to do that, right? So I talked about before, let's say like a machinist mate who's down in working in an engine room somewhere. I'd rather that person learn how to overhaul a diesel engine, or how to do repairs on a controllable pitch propeller system, or some other systems that are fairly complicated. And as John talked about in the wartime footing, that's not the time to learn, right? That's the time to act. And I didn't share a sea story, but I'll share a sea story of mine. So everyone probably who's been around for a while knows where they were on during 9/11. I was in Northern Australia, and we were in the North Arabian Gulf just a few days after the attack on 9/11. And when we got up to the NAG, I was actually on watch when it happened. We heard this horrendous ripping sound. It was cavitation of the CPP pump, the controllable pitch propeller pump. So cavitation started. We started investigating where the noise was coming from, what was happening. All of a sudden, we heard this just tremendous shearing metal sound. It was nothing I've ever heard before. I thought we got hit or something else, because and it shook the ship. It was a lot. Turns out we actually snapped a section of shaft. The shafts are sectional, and we had literally ripped them apart. And with just a handful of sailors, with low slow fires, fast attack boats, and things during 9/11, that's really the hairy situation. We were able to remove the OD box, remove the section shaft. We physically created a section of shaft on board, and got it installed. And that section shaft stayed on there for about 10 years. I mean, we did this underway. I mean, that's never been done before. And it's not to pat myself on the back. It's just to kind of highlight that's where my mind is on a lot of this. And I'd argue people who write about this or study this problem, that's where their mind is too, is, you know, if I had just had to learn what CPP was, or I'd only done minor maintenance on the system ever, there's no way we could have done that repair. Where I really had to have our P's and Q's together at that time. And that's what this gets at. We need to know how to operate and repair the gear. Peacetime is when we should be taking risks. And that's again that's why I talk about scheduling time for maintenance and doing it properly. Allow yourselves that time to be able to do those repairs, or to do the preparation, or to find ways to leverage shoreside, right? Shoreside is overhead, right? I don't make money, right? That's not what we do. We support the fleet. So, and I think a lot of shore people, sometimes we forget that. So, you know, for ship commanders out there and the guys out on the waterfront, you know, leverage shoreside to buy down that off from your shoulders, and allow your sailors the opportunity to go do those repairs and maintenance and dissect systems and do some of the more complicated parts, so that when the call comes, we can act quickly and with intent.
Indeed. Well, then, thank you, Captain John Cordle and Chief Warrant Officer Benjamin Miner, for taking time to discuss your article, Give Navy Crews Painted Ship, and everything else around the topic. I hope that I can welcome you both back on the show in the future to talk a little, learn a lot, the podcast of the American Society of Naval Engineers.
Yeah, thanks, Stephen.